Homework number 20. The first 5 questions ask you to perform some transformations. The first question asks you to write the new coordinate of point A after a reflection over the x-axis. In order to do that, you need to follow the reflection rule, which is that when you reflect over the x-axis, you change the sign of the y-coordinate. The new point will also be called A prime. The x-coordinate stays the same, but the y-coordinate changes signs. The second question asks you to perform a translation 2 units up and 3 units to the left. When you translate, you add or subtract to the x and y coordinates. The x coordinates move left and right, so this one would be changed by 3, since the direction is 3 to the left. When you go left, you subtract 3. When you go up, you add 2. So whatever the x coordinate is, we're going to subtract 3. So that would be b prime, and negative 5 minus 3 is negative 8. The y-coordinate will be added by 2. 8 plus 2 is 10. The third question asks you to rotate 90 degrees clockwise. When you rotate 90 degrees clockwise, you follow this rule. Swap the coordinates and change the sign of the second number. So we're going to swap the coordinates, just like they are, and change the sign of the second number. The fourth one asks you to dilate by a factor of 1/3. When you dilate, you multiply each of the coordinates by the scale factor. So negative 3 times 1/3 is negative 1, and 6 times 1/3 is 2. The last question asks you to write a math rule. It asks you to take this point E and transform it to E prime. So what happened? Well, as I can see, I have completely different digits. That doesn't happen when you rotate or when you reflect. But it can happen if you dilate or translate. There's nothing I can multiply 3 by to make a negative 1, so this must be a translation. So we can look at our rule here and see that the 3 has turned into a negative 1. So that must mean that we subtracted 4. And our y has turned into a 9. So that must mean that we added 2. Let's take a look at question number 6. 2 functions are described below. Function A says the fitness club charges members an initiation fee of $99 and an amount of $49 per month. So that equation is y equals 49x plus 99. The second function has an equation of 65x plus 25, which also charges a member a monthly fee and an initiation charge. Which statement correctly compares the relationship between function A and function B? Does function A have a greater rate of change? Well, function A's rate of change is 49 and B's is 65. So no, that's not true. Does function B have a greater rate of change? Yes. Does function B also have a greater initial value? No. The initial value is 25 for B, but it's higher for A. So cross that off. Function A has a greater rate of change. Nope, we already proved that is not true. So let's look at the last option. Function B has a greater rate of change. Yes. But the initial value for function B is less. Yes. So option D is correct. Question number 7 asks you which ordered pair prevents the following set from being a function. In order for you to determine if a set is a function, you look at the x values. Every input can only have one output, and this input, 3, can either come out as a 4 or come out as a 6. Its output is different. So this is preventing it from being a function. Number 8 asks you which equation represents a linear function. A linear function is an equation that can be written as y equals mx plus b. No powers, no special characters, no variables in the denominator, no variables timesing each other. This breaks the rule, this breaks the rule, and this breaks the rule. So C is the linear function. Questions 9 and 10 ask you to solve for x. So for number 9, I'm going to multiply 3/5 times x, and then 3/5 times negative 10, which is negative 30 divided by 5, which is negative 6. There's nothing to distribute on the right side. However, the right side does have 3 terms, 2 of which are x's. So I'm going to combine these like terms here. I'm going to keep the left side the same, and I'm going to add 2.5 with 3.5. And that gives us 6x. Now I'm going to add 6 to both sides, which actually cancels out. 0 and 0. So now I have 3/5 x equals 6x. I'm going to subtract 3/5 x from both sides, and that means that my left side will be a 0, and my right side will be 6 minus 3/5. So you can use a calculator to compute that. So I'm going to get 27/5. And now I'm going to multiply both sides by the reciprocal. This cancels out, and 0 times anything is just 0. Let's take a look at question number 10. When I distribute, I get 8 minus 4x equals negative 8x plus 32. I'm going to add 8x to both sides, giving me 8 plus 4x equals 32. I'm going to subtract 8 from both sides, which gives me 4x equals 24, and I'm going to divide both sides by 4, giving me x equals 6. Questions 11 through 13 ask you if something is linear or nonlinear. You are linear if you can be written as y equals mx plus b. No powers, no letters in the denominator, no special characters, and no x's times y. These don't break any rules, so they are linear. Numbers 14, 15, and 16 ask you if the graph or table is a function. If you're a graph, you would pass the vertical line test, meaning you never touch the graph at 2 different locations at the same time. So this is a function. But here, my vertical line would touch the graph multiple times. So this is not a function. When you have a table, you're looking for repeating x's with different y values. This is not a function. Number 17 asks you which equation is shown in this graph. In this graph, I see that the line is going down. That means it has a negative slope. so these are out. I also see that in order to get from one point to another, the rate of change is down 1 and right 2. Rise is -1, run is +2. -1 over 2. That concludes homework number 20.